I think my screen is visible to all of you. Response?
Yes, sir.
Okay. Uh, Today the next topic is transistor. I will start the next topic, and it is previously in your +2 level, all of you little bit learned about the transistor. So basically, whatever you know about the transistor, you know about only about the BJT. BJT means your NPN and PNP type of transistor. So it is the BJT. This BJT is named as bipolar junction transistor. All of you use the pen and paper and note down the thing. Bipolar junction transistor. So this is one of the type of transistor, BJT. Now this BJT, bipolar junction transistor, it is a current control device. Current control device. Now what is the meaning of current control device? Here in case of BJT, your input current control the output. Okay, so it is called current control device. Now you have the question that current is controlling the output. So when there is a current, there is also some voltage are there. Then why it is current control? Why not it is voltage control device? You know the linear device and non-linear device? Yes, no? Linear device and non-linear device. So first, linear device is what? Linear device, the device which follow the Ohm's law. The device which follow the Ohm's law and homogeneity equation. That are the linear device. So when device is following the Ohm's law, the nature of the current and voltage is like this. V is proportional to I. So it is a linear. But in case of non-linear device, this non-linear device, it does not follow the or does not follow the Ohm's law. Okay, so it is not follow the Ohm's law. Now, if it is not follow the Ohm's law, means your device characteristic is not linear. Okay, now this transistor is a non-linear device. So transistor is a non-linear device. Transistor is a non-linear device. That means its current and voltage characteristic is not linear. Okay, suppose this is the voltage, this is the current. So this graph is for the linear when Ohm's law is followed. So transistor is non-linear device. That means your transistor not follow the Ohm's law. Is it okay? Okay or not?
Yes, sir.
Okay. Now that means here your V is not proportional to I. This is not follow in case of transistor. Now when the V is not proportional to I, that means if the current is increasing, that doesn't mean your V is all increasing. Okay, it is not. Your V may be increase, your V may be decrease. Okay. Here in case of non-linear device, if the current is increased, your V is maybe increase, maybe decrease. Both will be happen. So it is non-linear. Okay. So here in this case, your current is your input current. Your input current control the output voltage or current. So now here your input current control the output current and voltage. So your whatever the input voltage is increase or decrease, that will clear. Unipolar device. Next is unipolar device and bipolar device. Unipolar device and bipolar device. What is it? Your unipolar device is unipolar device. देखो, in case of any semiconductor or semiconductor devices, current is flowing due to flow of electron and due to flow of holes. Now, unipolar device is what? Unipolar device is that device where current is flow only due to one type of charge carrier. One type of charge carrier. So in case of unipolar device, the current is flowing only due to one type of charge carrier. That is, either current is flowing either due to hole or either due to electron, not by both. In case of unipolar device, and in case of bipolar device, here the current is flowing due to both type of charge carrier. Due to both type of charge carriers. Means here current is flowing due to flow of electron and due to flow of holes both. Okay, in case of bipolar device. Is it clear? Yes, no?
Yes, sir.
Now, next here your BJT is what type of device? BJT is bipolar device. Your BJT is bipolar device. Why it is bipolar device? Anyone? BJT is bipolar device. Why it is bipolar? Because current is flow due to flow of both type of charge carrier, electron and holes. Is it okay? BJT is bipolar device because in case of BJT, current is flowing due to both type of charge carrier, current and holes. Now, next in case of transistor, all of you know it is two type of transistor BJTs. Two type of BJTs are there. NPN either it is NPN or it is PNP. Now, what are the terminals in BJT? Emitter, emitter, base, and collectors. Collectors. Same here. Emitter, it is denoted by E, base, and collector. Three terminals are there. Okay. So now, for making the NPN transistor or PNP transistor, how you have formed the NPN and PNP transistor? Here, either is a single semiconductor plate or semiconductor bar. Half there is P-type semiconductor is sandwiched between two N-type semiconductor, or N-type semiconductor is sandwiched between two P-type semiconductor. You will get the BJT. Okay. Now BJT have three terminals: emitter, base, and collector. It is two type: NPN and PNP. Now this NPN and PNP here, this terminal is emitter, this region is emitter region, this is base region, this is collector region. Here in case of emitter region, this emitter region, the this region is highly doped. It is doping concentration is high. It is highly doped. So whatever the impurity used either in NPN or it is in PNP, the doping concentration is high. Okay. Now next here, this collector region, the doping concentration is moderate. Okay, it is moderately doped. Means here this collector region is doping is greater than doping is less than emitter region and higher than collector region. Base region. Doping concentration is for the collector region higher than emitter and greater than base region. This base region, doping of this base is low doping. Low doping. Doping concentration is very low. Now next is the area occupied by this all region. Here this emitter region, its area or this width, this area or this width, it is moderate in size. Moderate in size means its area is greater than base region, but it is less than collector region. So it is the moderate area. Moderate area. Next, collector. So here collector area or this width of the collector, it is high or large. Okay, it is large. Area is large or width is large. Large area. and base this base width is very small. Base area or base width, it is very small in size. So this follow both in case of NPN and in case of PNP. Okay. Complete.
Yes, sir.
Okay. Next, what are the applications? Before that, all of you go with the symbol. I think all of you know the symbol, but I will just draw it. Symbol of the transistor. So here. To draw করতে এখানে অসুবিধা হচ্ছে just base emitter and this is collector. So this is for the NPN transistor. Base, collector, and this is the emitter. So this is PNP transistor. Symbol of PNP transistor. Just by this arrow sign, it is the difference. In case of PNP, arrow is inside, and in case of NPN, arrow is outside from the terminal. Okay. Next topic is, what are the application of transistor? Application of transistor. So first one is, it is used for designing the amplifier. You can note down, it is used for designing the amplifier. So what is amplifier first? You heard the term amplifier? Amplifier is what? Amplifier amplify the signal. Amplify means, suppose this is the amplifier circuit within this box, having the gain, suppose 4. So if you provide the input 2, then you will get the output 4 into 2. Means it will be, you get the output 8. So amplifier amplify the signal. Okay. Signal को क्या कर रहा है? बढ़ा दे रहा है. तो पहले 2 था. When it is passing through the amplifier, it is amplified and you are getting amplified version of signal. It is the amplifier. So this transistor most important application is it used for designing the amplifier circuit. Okay. Second one, it is used for designing the voltage regulator. It is used for designing the voltage regulator. Now, voltage regulator is what? Voltage regulator is a such type of device whose output voltage is constant even you change the input voltage. Means your input is changing, but your output is constant. This type of circuit is voltage regulator. And voltage regulator designed with the help of transistors. Is it clear? Next one is switches. It is used for designing the electronic switches. Okay. So It is used for designing the electronic switches. So these are the few application of transistor. Means on-off purpose. In case of switches, it is used for on-off purpose. It's on the circuit, it's off the circuit. Next is this BJT transistor. Up to this, okay? Anyone? Any doubt? If anyone have any doubt, you can ask. कुछ repeat करना है कि okay? Anuj, Anushka,
Yes, sir.
everything is okay?
Yes, sir.
समझ में आया ना?
हाँ सर,
अगर
आ रहा है.
कुछ इश्यू हो तो रोक सकते हो, बीच में पूछ सकते हो, ठीक है?
ओके सर.
Okay. Then I will continue for the next topic, and it is the most important application. Transistor is used as the amplifier. Can I change the page?
Yes, sir.
So next topic is transistor. How this transistor is used for the used as the amplifier, or how it amplify the signal. This I will discuss in the next topic. Now I will consider one type of transistor. So suppose I am considering the NPN transistor. So this is N, P. चेक काम करो थोड़ा सा रुक जाओ. N, P, N. So NPN transistor, suppose 3 terminals are there: emitter, base, and collector. Okay. Now this, when the transistor is used as the amplifier, your emitter base terminal, this emitter base terminal is forward bias. So forward bias. So emitter is N type. You can see here emitter is N type, and your base is P type. So when it is forward bias, your emitter is connected with which terminal of the battery? Emitter is connected with negative terminal, and P is connected with positive terminal. We also discussed this forward bias, reverse bias in case of diode. In case of forward bias, your N is connected with negative terminal and P is connected with positive terminal. So this is the forward bias. So in case of when the transistor is used as the amplifier, your emitter base junction is forward bias, and this collector base junction is reverse bias. So it is reverse bias. So N is connected with reverse bias, so it is positive, and your P is connected with negative. So this is the biasing. Biasing means how you are connected the supply to the device. Okay. Now, in case of this NPN transistor, here in N region, electrons are the majority carrier. Few numbers of holes are there, but electrons are the majority carrier. In case of P region, holes are the majority carrier. Holes are the majority carrier, and in case of N region, here these electrons are the majority carriers. We already discussed majority carrier, minority carrier. Okay, so majority carrier means in case of N region, huge number of electrons are there, few number of holes. So holes, electrons are the majority, holes are the minority. In case of P region, holes are large in number, electrons are less in number. So here holes is majority, electrons is minority. Same in case of N type, electrons are majority because it is in large number, and holes are minority because it is in low number. Now this, when this emitter base junction is forward bias, so here the electrons are the, these are the electron. So this is, here this battery terminal is negatively charged and this is the positive terminal of the battery. Now these electrons are negative. It is, these are the negatively charged, and these electrons, this is negative terminal of the battery and these electrons are have negative charge. So it repel the electron, means this electron have tendency to move in this direction. This electron have the tendency to move in this direction because this negative plate repel the negatively charged electron. Is it okay? This electron, by repelling this negatively charged terminal, it is moving in this way, this side. Now this base region, this base region, it is very low width. This width is very low. When you supply this forward bias, this electron have tendency to move in this side. Here this width of the base is very small. So when this electron is moving in this way, these are easily cross this region and move to this region. Okay, these electrons easily cross this region and move to this region because this width is very small. This width is very small. So this electron, after getting the energy, after repelling from this negatively charged battery, negatively terminal, it is moved from this region to this region. And here in this region, you can see electrons are there. So, and this terminal is positively charged. So these electrons are moving in this way, this side, and पहले से तो यहाँ पे इलेक्ट्रॉन था, but due to this emitter based forward bias, some more number of electrons are also come here from this region to this region, from emitter region to collector region. So the number of charge carrier, the number of electron in this region is increased. So here the current flow in this terminal is increased. So means here this current means current is flowing in this terminal. Here the current direction will be positive to minus negative, means current direction is this side in this terminal. So when this current is increased in this terminal, here the output current, this current will be increased here. Means, is it okay? Means here you are getting amplified version of signal across the output side. This is the input side, this is the input side, and this is the output side. This is the output side. This one is the input current. This is the input current, here IE, and this is the output current, here IC. So here input current control the output current, input current control the output current, IE control the IC, it is current control device. And suppose if you not supply this IE current, here the very less current is flowing, but when you supply the IE current, here the current in this output terminal will be increased. So you are getting amplified version of signal across the output side. Is it clear? This NPN transistor or PNP transistor, it is used for It is used for signal amplification, both type of signal amplification. It amplified the AC, it amplified the DC. Both type of signal is amplified by the transistors. Up to this, okay?
Yes, sir.
Okay. So next complete. Can I change the page? पेज चेंज करूं?
Yes, sir.
Okay. Wait a second. The next topic is FET. FET. Previous one is BJT. Next one is FET. BJT is bipolar transistor and FET is field effect transistor. Field effect transistor. So some properties are different from the BJT. Your BJT is bipolar device and this FET is unipolar device. Polar, PO, unipolar device. So why BJT is bipolar? Because in case of BJT, current is flowing due to both type of charge carrier, either both type of charge carrier, electron and hole. So that one is bipolar. Here, in case of FET, one type of charge carrier, current is flow only due to one type of charge carrier. So either electron or hole, not both. In case of the FET, here the current current is flow due to one type of charge carrier, either electron or hole, not both. So it is unipolar device. Is it clear? Second one, previous one is current control device. In that case, input current control the output current. Here in this case, it is voltage control device. Voltage controlled device. Now, why it is voltage control device? Same. First, it is what? It is the non-linear device. Same as the BJT. FET is also non-linear device. Non-linear device means if the voltage is increasing, that doesn't mean your current is also increased. It may be increased, it may be decreased. Okay, so it is non-linear device. Non-linear device. First one is voltage. This FET is non-linear device. Now, why it is voltage control? Because in case of FET, your input voltage input voltage control the output voltage or output signal or output whatever. So your input voltage is control the output voltage. So it is the voltage control device. Just opposite to previous one. Okay. Now next is wait a second. Hello. Okay, next is, wait a second. You can note down. Just একলাইন লিখে নাও, যেটা বোঝালাম সেটাই বলে দিচ্ছি। In case of FET, FET, the output is controlled by applied input electric field, that means voltage, applied input electric field. So it is called voltage control device. So it is called voltage control device. Next is same as your BJT. Your BJT is of two type, NP and PNP. Your FET is also of two type, and first one is JFET. It is of two type. FET is of two type. So JFET, junction, field effects, transistors. Junction, field effect, transistor. Can I change the page? পেজটা চেঞ্জ করব।
Yes, sir.
Yes, sir.
ওকে, তো JFET, junction field effect transistor. Now first we see the construction of this JFET. In case of JFET, one type of semiconductor semiconductor plate or semiconductor bar is there. It may be N type or P type. So suppose we are taking the N type semiconductor bar. In this N type semiconductor bar, some portion at the top of bar is doped with P type impurities, highly doped with P type impurities, and this region is also highly doped with P type impurities. P plus means highly doped with P type impurities. Now, this region, this is your one of the terminal, and this terminal is called gate, 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 and it is denoted by G. Beside that, there are other two terminals. One is this one. It is called source, S, and other is this one, other side of the bar, and it is called drain. So same as the NPN transistor or PNP transistor, BJT, three terminals are there, and the terminals are source, drain, and gate. Now this JFET is also of two type. JFET junction field effect transistor is of two types. This whatever we are designed here, it is N channel. It is called N channel JFET. And in case of P channel JFET, two types of JFETs are there. Either it is N channel JFET or P channel JFET. So this is the construction of N channel JFET. One single semiconductor bar or plate is there. This bar is moderately doped with N-type impurities. On this bar, two P plus region are created, like so in the figure. And these three terminals, one terminal from the this bar source, other is drain, and by joining this two P plus region, the third terminal will be gate. So these are the three terminals: source, drain, and gate. Now next one is P channel. So for P channel, just opposite of the previous one, here your bar is of just opposite. This bar is of P type. Bar is of P type. Above this P type, here N plus region is created. Below here N plus region is created. Now, by joining this to N plus region, this is the gate terminal. Gate terminal. And this one side is source terminal. And other side is drain terminal. So this is for the P channel JFET. Clear? You can see the difference in the construction. ठीक है? बोलो हाँ.
Yes. हाँ sir.
Can I change the page?
Yes, sir.
Okay. Now we discuss the working of this JFET, either N channel or P channel. So I will just discuss the one, and rest will be same. So suppose I am drawing the N channel JFET is there. So for the N channel, this bar is of N type. Top side P plus region. Bottom side P plus region. These two P plus regions sorted. There is the gate terminal. One side is source terminal and other side is drain terminal. अच्छा एक चीज है, देखो इसमें एक साइड सोर्स है, दूसरा साइड ड्रेन है. कौन सा सोर्स होगा, कौन सा ड्रेन होगा, इसमें थोड़ा सा डिस्कशन है. You can see here this bar is of N type. So for N type, what is the majority charge carrier? For N type semiconductor, majority charge carrier, electron. Okay. Now electrons are the majority charge carrier. अब देखो source क्या होता है? Source is that region where majority charge carrier enter from that region. जिस रीजन से मेजोरिटी चार्ज कैरियर इंटर करेगा वो सोर्स रीजन होगा, और जहां से मेजोरिटी चार्ज कैरियर आउट होगा वो ड्रेन होगा. तो हियर दिस इज एन टाइप सेमीकंडक्टर, मेजोरिटी चार्ज इलेक्ट्रॉन. तो जहां से सोर्स इलेक्ट्रॉन इंटर होगा फॉर दिस, जो भी मेजोरिटी चार्ज कैरियर होगा, जहां से मेजोरिटी चार्ज कैरियर इंटर होगा, दैट रीजन इज सोर्स, एंड द रीजन थ्रू विच majority carrier outs, that region will be the drain. Okay, you can note down the terminal through which majority carrier enters. The terminal through which majority carrier enters is called source terminal, and the terminal through which majority carrier out or leave out is called drain terminal. Okay, now you can see, देखो, here this is source and this is drain. Now after that, first we connect the supply between source and drain. तो सोर्स और ड्रेन में सप्लाई कैसे क्रिएट होगा? सोर्स और ड्रेन में सप्लाई कनेक्ट करना है, तो कैसे सप्लाई कनेक्ट करना होगा बताओ? Here current is enter from the source region. तो करंट को, सॉरी करंट नहीं, मेजॉरिटी कैरियर इंटर फ्रॉम द सोर्स रीजन. तो ये एन टाइप सेमीकंडक्टर है. तो इफ इट इज कनेक्टेड विद नेगेटिव टर्मिनल, देन व्हाट विल हैपन? एंड डी इज कनेक्टेड विद द पॉजिटिव टर्मिनल. उस केस में क्या होगा? इन दैट केस करंट इज फ्लोइंग इन दिस वे. ऐसे करंट इसमें फ्लो होगा. Current is flowing in this way. Clear? Current is flowing in this way. अब इलेक्ट्रॉन इसके में कैसे फ्लो होगा? इलेक्ट्रॉन जो है करंट के डायरेक्शन में फ्लो होगा, तो इलेक्ट्रॉन भी इधर ऐसे फ्लो हो जाएगा. ओके, तो ये तो फॉलो नहीं कर रहा है इसको. इलेक्ट्रॉन मेजॉरिटी कैरियर इट अपोजिट हो जा रहा है. मीन्स हम लोग का जो बायसिंग जो हम लोगों ने किया है, इट इज रॉन्ग. So we change the biasing here. So we change the biasing. So for changing the biasing, this source is connected with positive terminal of the battery, and drain is connected with negative. Okay. Now the current is flowing in this. Wait. भूल हो रहा है. Wait a second. Hello. Your electron flow is flowing just reverse to the current flow direction. Electron is flowing just reverse to the current direction. You can note down. Electron is flowing reverse to the current direction. Previous one is okay. This one is wrong. Here. Here current is flowing plus terminal to negative terminal, plus to minus. So current is flowing through this path. Current is flowing through this path. Current is flowing through this path, positive to negative terminal, and electron is flowing just reverse. So electron is flowing just reverse, means negative terminal to this. So here current is entered from the source region. This is the biasing between source and drain. Is it okay? Now next is your gate terminal. Now see here, if you not connect the voltage to this gate terminal, you connected the supply between source and drain, means suppose this voltage, suppose it is VDD, suppose. So you supply the voltage VDD. So if you increase this VDD voltage, your current will be increased. This drain terminal current, it is suppose here ID. So this ID will be increased. So if you increase this voltage, your ID will be increased. Now, if you this gate terminal, how it is effect? This gate terminal, this is always reverse bias. Your gate terminal is always reverse bias. Now, this gate terminal is, you can see, it is connected with the P-type terminal. It is reverse bias, means it is connected with which polarity? It is connected with reverse bias, so negative polarity. Okay, so this gate terminal is reverse bias. Suppose this VGG is the gate voltage and this reverse voltage is given to this gate terminal. Now, what is the effect here? Now, if you increase this voltage, there is the, if you remember the PN junction diode, when this PN junction diode is reverse bias means P is connected with negative terminal of the battery, N is connected with positive terminal battery. Here the width of the depletion region, it is increased. If you increase this voltage, this width of the depletion region increase. If you again increase this voltage, this width is again increased. Okay, the width of the depletion region increase. This is the property of reverse bias. Now, when you increase this reverse voltage, here this depletion region, this is P type and this is N type. It acts as PN junction. This is P side, this is N side, this is N side, this is P side. So this is act as PN junction. Now, when you increase this reverse voltage, when you supply this reverse voltage, there is a creation of depletion width. There is a creation of depletion width. Clear? If you apply the VGG, here depletion width is added in the path of current flow. Clear? Yes, no? नहीं समझ में आ रहा है, ज्यादा हो गया है तो बता दो.
यस सर, समझ में आया सर.
समझ में आ रहा है, ठीक है. तो ये जो P रीजन है, ये रिवर्स बायस हो रहा है, गेट टर्मिनल रिवर्स बायस हो रहा है, तो देयर विल बी क्रिएशन ऑफ डिप्लीशन रीजन, सेम एज PN जंक्शन डायोड. तो देयर विल बी क्रिएशन ऑफ डिप्लीशन रीजन. तो इसमें होता क्या, देखो, जब ये वोल्टेज हम लोगों ने नहीं दिया था, इन दैट केस व्हेन यू सप्लाई दिस VDD, दिस करंट इज फ्लोइंग थ्रू द सेमीकंडक्टर बार. इस बार के इस पॉइंट से करंट. अब देखो, जब ये वोल्टेज प्रोवाइड कर रहे हो, तो ये जो जहां से करंट फ्लो हो रहा है, तो यहाँ पे डिप्लीशन रीजन क्रिएट हो जा रहा है, और डिप्लीशन रीजन से करंट फ्लो नहीं होगा, तो जो पाथ है, जिस पाथ से करंट फ्लो हो रहा है, वो क्या हो रहा है, घट जा रहा है. द पाथ थ्रू विच करंट इज फ्लोइंग इज रिड्यूस. पहले पूरे बार से फ्लो हो रहा था, अब क्या इतना साइड रिड्यूस हो गया दोनों साइड से, तो अब अब थोड़ा अब यहां से फ्लो हो रहा है. इज इट ओके? जब डिप्लीशन रीजन नहीं था तो पूरा बार से फ्लो हो रहा था. अब जब डिप्लीशन रीजन क्रिएट हो गया, तो दिस थ्रू दिस पोर्शन इट विल नॉट अलाउ द करंट फ्लो, जहां पे डिप्लीशन रीजन है, तो उसके बाद यहां से करंट फ्लो होगा. क्लियर? इफ यू अगेन इंक्रीज दिस वोल्टेज, देन again there is the creation of depletion width is again increase. Depletion width is again increase. The path through which current is flow, it is decrease. So this ID will be decreased. If you again increase this reverse voltage, gate voltage, VGG, this is again increase, and this path is again decrease. This ID will be again decrease. Means your VGG, this voltage control the output current. This VGG control the output current. So since you can see it is voltage control device, because here this input voltage, this is the input. this input voltage control the output current. So it is voltage control device. Okay, and in this device, this output current is controlled by the help of input voltage VGG. Okay, if you again increase this VGG, this path is again, this depletion which is again increased, and maybe the whole path is blocked and current ID will be 0, not current is flowing. Okay, this full path is blocked by the depletion region and current is not flowing. It may be possible. This is the working. Now, working is clear to all of you. Here the input voltage VGG control the output voltage. Clear?
हाँ सर।
लिखवा दूं क्या? लिखवा दूं या ओके?
नहीं सर, भूख लग गया है सर।
चलो ठीक है। चलो फिर मैं जब भूख लग गया तो इसमें जस्ट एक टॉपिक है पिंच ऑफ वोल्टेज, बस उसको बोल के मैं बंद कर दे रहा हूँ। ठीक है, इस टॉपिक में जस्ट एक वोल्टेज है, एक टॉपिक है यहाँ पे, पिंच ऑफ वोल्टेज। जस्ट नोट डाउन दो। कहाँ गया पिंच ऑफ वोल्टेज? पिंच ऑफ वोल्टेज ये क्या होता है? देखो, व्हेन यू VGG इज इंक्रीज, जब VGG इंक्रीज कर रहे हो तो एक टाइम ऐसा आएगा जब तुम्हारा पूरा पाथ जो है ब्लॉक हो जाएगा और करंट फ्लो नहीं होगा। तो VGG पिंच ऑफ वोल्टेज क्या होता है? इसको VGS ऑफ बोलते हैं। VGS ऑफ। तो देखो ये VGS मीन्स गेट टू सोर्स वोल्टेज। गेट और सोर्स के बीच में जो वोल्टेज है वो VGS डिनोट करता है। तो पिंच ऑफ वोल्टेज क्या होता है? देखो, जब ये VGG इंक्रीज कर रहे हो तो गेट टू सोर्स वोल्टेज क्या हो, इंक्रीज हो रहा है। तो एक ऐसा टाइम पे आ रहा है जहां पे करंट, आउटपुट करंट 0 हो जा रहा है। तो उसके बाद अगर VGG और इंक्रीज करोगे तो आउटपुट वैसे ही 0 हो गया, वो 0 ही रहेगा। तो VGG क्या है? VGG इज, और पिंच ऑफ वोल्टेज क्या है? इट इज द मिनिमम वैल्यू ऑफ गेट टू सोर्स वोल्टेज फॉर विच द आउटपुट करंट इज 0। पिंच ऑफ क्या है? इट इज द मिनिमम वैल्यू ऑफ VGS गेट टू सोर्स वोल्टेज for which output current is 0. You can note down pinch of voltage. Pinch of voltage is the minimum value of VGS get to source voltage for which the output current ID is 0. It's called pinch of voltage. Okay. अगर उसके बाद फिर से उसको बढ़ाओगे तो फिर वो 0 ही रहेगा, क्योंकि ऑलरेडी पूरा चैनल ऑलरेडी ब्लॉक हो चुका है। क्लियर? बस चलो, काफी लोग थक गए हो और कुछ लोगों को भूख भी लग गया है, तो आज के लिए बस इतना ही रखो। वेट ए सेकेंड।